Alright, today we're going to start talking about convection currents. This is kind of a review in a sense that we've already learned what convection is back when we were talking about molecules and how substances get heated and transfer heat. So convection is that circular movement of liquids or gases where hot substance will rise, and as it cools it will begin to sink. So we're going to be specifically talking about magma in the mantle for one, and as that magma gets extremely hot, it starts to rise. As it moves up towards closer to the surface or to the crust, it starts to cool and will sink again. These circular movements will cause what we know a convection current. Those convection currents in the mantle cause our tectonic plates to move that are lying on the lithosphere. Another place in the Earth's interior where convection currents occur is in the outer core. And that liquid hot metal, iron and nickel, as it's spinning, it generates a very weak but very important magnetic field for our Earth, which protects us from very harmful things, especially from the sun, like solar flares. And we'll talk more about that later on this year. Okay? On the next page here, I want to demonstrate how convection currents, let's show real quick here, how when they're spinning, they move these tectonic plates. Okay, so here we have our convection currents. Oops. Let's lock that in place. So convection currents, move this down a little bit. Convection currents spin, okay, like this. That hot magma is rising. As it starts to cool, it sinks. So they're all spinning. Okay? They all spin like this. As they're spinning, they're going to move the tectonic plate one way or the other. Okay? That's why our tectonic plates move. This blue line is representing our lithosphere. And right underneath our lithosphere, we have these convection currents that are spinning and turning this hot magma, rising as it's getting hotter and sinking as it's cooling. And as they're spinning, they're moving this tectonic plate. Okay? So another picture I wanted to show you, maybe to demonstrate a little bit better for you and give you a better visual as to how these convection currents are moving these plates. I have here, I want to move. So this tank, I'm sure you've seen a tank, whether it be in the movies or maybe you've even been lucky enough to see one in person and really be able to take in what it looks like. But our green parts here are going to be the movement on that tank, and they're going to represent our tectonic plates. The red parts here are representing the convection currents that are going to be like the tank's wheels. Okay? So as these convection currents are spinning, they are moving the green part, and it turns, and it's moving this way. In turn is moving the tank, because the tank is sitting on top of it. So our tank represents our continents. Okay, so as the wheels are spinning, or the convection currents are spinning, oops, okay, that starts to turn the green and that starts to move, and on top of the tectonic plates are the continents, and those begin to move as well. So let's talk a little bit more too about some other facts that we should know. A constant flow begins as the cooler, denser magma sinks to the bottom. Then the warmer, less dense magma rises. A convection current is the flow that transfers heat within a fluid. And a fluid, we've talked about before, is either a gas or a liquid. So here's the process. Number one, there's a heating and cooling of the magma. And that changes in the magma, those changes in the magma changes the magma's density. And the force of gravity combines to set convection currents in motion. That starts to make them spin. Convection currents would stop without a constant source of heat. Where does it get its constant sort of heat from? From the core. Lastly, it's important for us to remember what density is. Density is a measure of how much mass there is in a volume of a substance.